Today, we're going to talk about the fire resistance of rammed earth. Now, the ideas we're exploring come from Gokul Salvadi's book, The Memory of Rock, Understanding Rammed Earth. And really, the whole subject comes down to a simple question. How does this specific kind of wall behave when it's subjected to intense heat? And that's, well, it's not a metaphor. It's a statement of basic chemistry. And it's really the only place to start if you want to understand how rammed earth interacts with fire. Because the truth is, its fundamental interaction is, well, it's one of non-participation. So to really get a handle on that idea of non-participation, we have to first be very clear about what rammed earth actually is. You see, it's not a product in the way we usually think of building materials. It's something closer to a consolidation of geology. What you're looking at is a composite of minerals, things like quartz, feldspar, and various clays. I mean, these are the fundamental components of the Earth's crust. They were created under incredible heat and pressure over geological time. So when you build a rammed earth wall, you're not really manufacturing a new product. What you're doing is, essentially, recompacting a piece of that ancient geology. Okay, so you cannot ignite quartz. To understand why, we have to think about chemical stability. Burning, combustion, it's just a rapid oxidation process. It's a chemical reaction that releases energy. But the minerals in rammed earth, things like quartz or the iron oxides that give it color, they're already fully oxidized. A good way to think about it is that they have no chemical energy left to give. On a planetary timescale, you could say they've already burned. There's simply nothing left to ignite. So the way rammed earth responds to fire, it probably makes the most sense when you put it side by side with more conventional building materials. Because most other materials fail in very active and often pretty destructive ways. Right, so let's look at this. Wood, obviously, is organic. It burns. Steel, well, it doesn't burn, but it loses its structural strength at the temperatures you'd find in a typical house fire. And then you have concrete, which can fail pretty violently. Any trapped moisture inside flashes to steam, and the pressure can cause the surface to literally explode outward. This is called spalling. Rammed earth, on the other hand, its response is passive. The surface that's directly in the flame will calcine, which is really just a technical way of saying it dehydrates and becomes powdery, kind of like baked clay. And this is the key, this effect is only a few millimeters deep. The core of the wall, it remains completely sound. Okay, so the natural question is why? Why is the damage only superficial? And the answer has to do with the physics of heat transfer, specifically heat transfer through a very dense, massive material. It's not just about what the material is made of, it's also about how much of it is there. The heat just crawls. And it all comes down to a concept called thermal mass. Think about it. A typical rammed earth wall is about 300 millimeters thick. That's about a foot. That is a tremendous heat sink. So when a fire hits one side, that heat energy gets absorbed, but it moves through that incredibly dense material so slowly. I mean, in the entire duration of a typical house fire, the heat just doesn't have enough time to penetrate deeply enough to compromise the wall's structural integrity. So that outer layer, it essentially sacrifices itself, while the core stays cool and stable. So we've talked about structural collapse, and that's obviously a huge danger in a fire. But the more immediate threat to life is almost always the air that you're breathing. And it's here that this distinction between these materials becomes, well, even more clear. See, in a modern house, the walls themselves can become a source of both fuel and poison. Your typical wall assembly has multiple layers: insulation, vapor barriers, wiring, paint, finishes. And many of those are polymers, plastics. So when they get hot, they don't just burn, they release a whole complex cocktail of toxic gases. But in a rammed earth house, the walls are just inert. They're a passive mineral mass. They don't add any fuel to the fire. And just as critically, they don't undergo chemical changes that release toxins into the air. The fire is contained to the contents of the room. The furniture, the curtains, not the actual structure surrounding you. And this is so important because most fire fatalities are from smoke inhalation, not the flames themselves. For example, burning foam insulation can release hydrogen cyanide. Burning wood produces carbon monoxide. A rammed earth wall simply does not do any of this. It's not off-gassing a cocktail of lethal toxins. It's not adding to the smoke. And because it's this solid, monolithic thing, it also functions as a default firewall, which can stop a fire from spreading from one space to the next. Okay, so let's shift gears and think about the aftermath. What happens after the fire is out? Because here again, the difference in how the materials behave leads to a huge difference in the outcome. With a conventional building, a major fire often means the whole thing is a write-off. It has to be demolished. The wood framing, the steel beams, they're often compromised beyond repair. But with a rammed earth structure, the building itself is still there. The damage is largely superficial. That calcined surface, it can be repaired. But the core, the load-bearing structure of the wall, is still perfectly intact. And it's important to understand that this isn't some kind of selling point. It's not a feature that's been added to the material. This is just physics. It's an inherent property of the material itself, a direct consequence of its geological origin. The wall behaves this way for one simple reason. It is, fundamentally, rock.